Okay, here's the second part of this fine. Ooh, my battery's going low on my slate. Okay, on number one, there's a million different answers you could have. For a third degree binomial, you can only have two pieces. So something plus something or something minus something, and then the exponent has to be something x to the third somewhere, okay? So that's what you have for number one. Something that's not a polynomial, you could have a logarithm, you could have an exponential, you could have an absolute value. The possibilities are endless on that as well. Okay, this one, you feel like you're doing something wrong because there's no like terms, but that's okay. You could double distribute or do the rectangle if you want. So it's a 3ab minus 5ac plus 7a. And now with a 4, so it's a plus 12b. Neat. Minus 20c, I feel like. And a plus 28. Weirdo, but it's okay. Now, this one, I tried to kind of write it out on the review because this would have been a commonly missed question because it's kind of wordy. Okay, so if b is a 0, so that means like say you have a graph, and so let's say that it's 2. Let's say that it's 2. So if 2 is a 0, which of these is not true? Does p of 2 equal 0? Yeah, p of 2 equals 0 because that's the definition of that. Is b going to be a factor of the leading coefficient? Well, I don't know about that one yet. Is x minus 2 a factor? Yes, it is. So that's true. And is b the x-intercept? Yes, b is the x-intercept. So that means that this has to be the answer. On this one, you are going to have to, you don't have to graph. Let's look here. A fifth degree polynomial. So there's five total zeros, and they already factored it for me. How many of these are real? Well, this one, and this one I can get right away because I can see them. The real ones are going to be 0, 2. And if you solve that to equal 0, 5x minus 7 equals 0, you would add 7 and divide by 5, and you would get 7/5. Are these real? Well, it can't factor anymore. So this one you're actually going to have to solve. So how many are real? There are 3 real ones, which means there are 2 non-reals. Remember, non-reals always come in pairs, so this should make sense to you. You could do quadratic formula, or you could complete the square. The closest square this would be to be an x minus 2 squared. So you would have your x squared, and you'd have 2 over here and 2 over here, which leaves 4 in the corner. But it says that there's 8. So I would have to add 4 more. If I set that equal to 0, I would subtract 4, square root both sides, don't forget your plus or minus. Square root of -4 is plus or minus 2i, and then add 2. So the last ones would be 2 plus or minus 2i. This one's kind of tricky. That was a trickier one. Okay, question number 5 here. They give you a graph and they want to figure out what this k is, okay? So just write the equation. Look, -3 is a single root, so it's an x plus 3 factor. And this one's the double root, which is an x minus 2 squared. So if you double distribute this out, you'll get x plus 3, x minus 2, x minus 2. I like to do this fart. I said fart. Part first. X plus 3 times x squared minus 4x plus 4. You might be able to figure it out here, or you could finish it up. X cubed minus 4x squared plus 4x. I'm still laughing that I said in fart. Plus 3x. I don't even know if you're listening. Minus 12x plus 12. Okay, this makes me kind of feel good. For starters, because I said fart, and for second, because I know I did it right. Because look, x cubed minus x squared, and then the plus 12. So this part, 4x minus 12 tells me what k is, and k should have been -8. -8. Good times. Could have been worse things I said. This guy here, fourth degree polynomial. So x to the fourth. Here are the roots. Okay, let's just write it in factored form. If we have 1 at -2, y equals, that'll be an x plus 2, an x minus 1, and then an x minus 5 squared. Okay, to graph it, you're going to type this into your graphing calculator. wonder if mine's still there. No. Okay. So I'm just going to leave it in factored form so I don't screw anything up. And I'm going to change the window to match what they told me. What was the window? Oh, sad. That's sad. What the? Come on. Come on. It was -6 to 6 and then -100 to 100. -6. Kenna, I think your teacher's here. -100 to 1. I don't. Well, I see cars pull into the driveway. A car. Yeah, that looks okay, right? And then there's my x-intercepts, which you probably could have already drawn that out. But here, if you do second, calculate, minimum, enter. Her teacher's here. She's so happy. Oh my God, my heart. You guys can be happy when you see me one day. And this is this ballpark. Just put that dot ballpark where it's supposed to be. You should repeat that over here, the second calculate maximum. Okay, so that'll be that. Not too bad. Oh my gosh, it did it again. I am raging out here. Okay, I'm so over this. I bet you guys are over this too. Okay, and this guy, we're just going to multiply. So length times width times height, guys. And h plus 1. I like to do the two pieces first. Kenna, was your teacher here? Is that happy? My students don't care if they see me. H to the third, they might. They might. What? We have to go where? We gotta go. Is that what she just said? All right. Okay, there it is. We're a little off track here, guys. I'm sorry this is happening. Okay, these last two are the ones you care about, though. Okay, so fifth degree. That tells me how many roots there are. There's 5. There's no multiple roots. So how many of these are non-real? Well, I see 3, total of 5, so 2 are non-real, and that's what you write. Number 9 was the hardest on the test because we don't really talk about all this. I wondered if you'd be able to figure it out or not, but the 2 is what makes this really hard, the 2 in front. Okay, so some of them are, you can see the rational. See what I did, you can graph this, but they give me a graph. But the problem is this one. This one is rational at -3, and then these 2, you're like, are they irrational or what? They all 3 cannot be irrational. One of these has to be rational because irrational only comes in pairs. So then what I did, I got to write this down because you know what it's going to do? It's going to go away again. 2x to the 4th plus 15x to the 3rd plus 26x squared minus 5x minus 6. Okay, so if I graph this bad boy, okay, 2x to the 4th. Oh, sad. Plus 15x to the 3rd. I'm trying to teach. What? You got an award? What was your award? Computer whiz. Oh, she's a computer whiz, guys. That's nice. Are you embarrassed now? My students know. Well, if they're listening, they know. My daughter is a computer whiz. She got an award. I'm so proud of her. Okay, Kenna, I have to teach him. Oh, good. You could take Miss Margary on adventures. Okay, here we go. I'm graphing it. So that's just what. Is that what they told me? I wonder. Did they change the window on it? -6. Yeah, about -40 to 40. Let's change this window. -6 to 6 is fine, but let's look at -40 to 40. Okay, just to make sure we're looking at what they're looking at. Okay, so we're curious about these in-betweeners. So you can do the second calculate 0, or you could go to your table and you can change your table to go like by 0.1s or something. Because you're looking for another x-intercept. Oh, damn. And there it is. It's at, oh, maybe there it isn't. There it is, 0.5. 0.5 is the other x-intercept. So that one is also rational, is at 1/2. So this is what would be confusing to you. When you write your factors, it'll be x plus 3. You could write x minus 1/2. That's not technically wrong, but at the end, you're going to have to multiply everybody by 2. What this really means is x plus 3 and 2x minus 1 are the two factors. And then what you will have to do is you'll have to long divide it out, which is disgusting. Disgusting. So this is what? 2x squared plus 6x minus plus 6 minus 1. So it's plus 5x minus 3. Okay, and then you could divide it out of this big guy. I don't want to write that out again because I'm a lazy bum. Get it there. Okay. So I'm going to divide this by 2x squared plus 5x minus 3. And I didn't get to do this with you, so we might not be superstars at this yet. 3 pieces, so go 3 pieces in to where you start. How many times does 2x squared go into 26x squared? I'm a liar. How many times does 2x squared go into 2x to the 4th? And it goes in there x squared times. Multiply down 2x to the 4th plus 5x to the 3rd minus 3x squared. Change the sign, change the sign, change the sign. So this is gone. And I have 10x cubed plus 29x squared minus 5x. I hope so. This is a little sloppy. How many times does 2x squared go into 10x to the 3rd? That's 5x times. Multiply down 10x to the 3rd plus 25x squared minus 15x. Change the sign, change the sign, change the sign. 4x squared plus 10x minus 6. This should work out nicely, and it will. It has to work out nicely because it is a factor. 2x squared goes into 4x squared 2 times. Almost done, Ken. 4x squared plus 10x minus 6. Change the signs, remainder 0. So then the last factor is x squared plus 5x plus 2. So this down here is the answer for B. And then to find the irrational roots, we're going to have to do quadratic formula there. X equals negative b plus or minus square root b squared minus 4 a times c all over 2a, which is 2, negative 5 plus or minus the square root of 25 minus 8. 17? I don't remember that, but maybe that's right. Okay, I don't know if I made a mistake there or not, but that's basically what you do. Okay, so that's a chapter 7 test. All I have left to do is make you that final, and we be done.